Okay, good afternoon. Welcome to the Open Data Institute. My name is Anna Scott. I'm the editor here, and I'm delighted to introduce Ben Nickolls from Libraries.io to talk about mapping the open source network. Apologies, we're running a little bit late today. Ben had a few tube dramas, but is here now, so I'll pass you over to Ben.
Yes, hello everyone. Sorry for the late start. I was saying just a second ago, you'll find that we're probably exactly the number of minutes late that it takes to walk from Lancaster Gate to Marble Arch because Lancaster Gate station was shut. But we're here now, it's all good. Thank you everyone for tuning in and for coming today to hear me. I'm going to be talking kind of a bit of a fireside chat rather than a lecture, and I can't see anyone eating their lunch, so yeah, lunchtime lecture. I'm going to be talking about building a free and open source software search engine and some of the impact that this could have on building a stronger, safer and sustainable open source ecosystem. I don't have my presenter notes with me, so forgive me if I flip forward and backwards so that I remind myself where I'm going, but I may have to do that. So this is me, my name's Ben, hello. I am nicer than this photo might imply, I promise, but this is the photo that you may have seen if you've found me on the internet anywhere. The reason for this photo is that I'm really angry, so I walked halfway across Vienna for that coffee, and it was crap. So that's me, and I work with this guy, Andrew Nesbitt, who you may know from several things. You may know him from 24 pull requests. You may know him from split.ruby, which is an A/B testing plugin for Ruby, or you may know him from the London Node user group, which he set up yonks and yonks and yonks ago. We now both live in and around the Bath area in the southwest, and we work on a project called Libraries.io, which is a project that's been going for about 2 years. Andrew created it, I think it was September 2015, launched it the following March. No, it's the year before. September 2014, launched in March 2015. And basically what it is a big repository of data about software. Principally, its kind of primary purpose is as a search engine. I'm going to go and talk through some of the aspects of how we built Libraries.io, some of the things that we can do with that data, and then some of the impact that that could have. But first of all, what I want to do is just do a bit of an origin story. So just want to ask this question, do we need yet another search engine, really? The answer to this question is think back to kind of 2014, 2015. What other options are there and what merit do they have? Apologies in advance for I'm going to be doing a little bit of bad mouthing about people who I actually have quite a lot of respect for. So here you go. Number one, GitHub. Hello. So GitHub, massive success story. GitHub is responsible in part for the kind of explosion of open source software. You can see here, this is GitHub's search facility, so /search. Enables you to search more than 58 million repositories. The last time I did this presentation, just over a year ago, I think it was about 24, 26. So we're talking about a kind of 2 times factor over the course of a year, and I think it's been growing at that rate or higher since it started, basically. So a massive repository of data, a huge kind of potential to provide a really great search engine for software. And what do we get? We get something that focuses predominantly on stars. So especially in 2015, there have been some changes that have been made, but as a result of that, you get things like this happening. So it kind of makes you think a little bit about the value of a star. This is actually my favorite project on the internet. It's called F off as a service. It solves the quintessential problem of telling someone to F off with a nice little RESTful API. It's got really nice modes to it. You can do a Malcolm Tucker kind of thing. And basically, it's just a joke project, right? And yet it garners 1,607 stars, which actually makes it one of the kind of top-tiered projects on GitHub. Similarly, we have a project called Volkswagen, which is just for the lols, basically. This was back in the whole kind of Volkswagen defeat device debacle that was emerging in the media. Someone thought it was a great idea to create a package that would basically detect whether or not your software was running as part of a kind of continuous integration service and just pass all the tests. Great lols, awesome. Also garners nearly 6,000 stars. Not the most valuable project in the world necessarily, but pretty fun. So basing a search engine around stars, probably not the best factor. And I just pulled up a quote here from Arthur Smith last year on changelog, I think it was. So Arthur, who was working at the time at GitHub, now works at NASA, said stars on GitHub are a measure of attention more akin to a like on Facebook than a measure of quality or usage. So just thinking about projects that you might have starred on GitHub, I assume some people here might have starred a project on GitHub. How many of you have actually unstarred a project on GitHub? Fewer, maybe. So yeah, not a great measure of usage, popularity, a great kind of basis for a search engine. What else do we have? So we have things like this. So this is RubyGem's search engine. If you look at this page, can you guess what the main factor that they're searching by is? It's going to be downloads. So downloads might not be the best way to build a search engine as well, because you have things like this. This is the logo for Travis, a popular CI tool. And I'm not blaming Travis particularly, but some CI tools, maybe including Travis, I looked at the config, will overinflate the amount of downloads that you have for dependencies for particular software that you might use in your own application. And actually, there's a reason to suggest that they might have some perverse incentives in order to do that, because if you look at package managers, a number of downloads might be an indicator of success, kind of stickiness for that particular package manager. And also we might have particular package managers that don't resolve all of the duplicates within their dependencies. So you'll end up with multiple pulls within a dependency tree of the same package multiple times for each time you compile, rebuild that project. So me, just now, I'm going to say that download counts are a good indicator of the low cost of I/O in networks. So with the alternatives kind of mitigated a little, basically we're saying we think we need something else. The kind of key question that we want to ask ourselves is, what do we mean when we say most popular? So for a given problem, for a given kind of thing that I need to do in my project, what is everybody else using to get that thing done? What is everybody else kind of relying on? So we think one of the best ways of doing that is to use this. So this is a gem file, and if you're not a developer, basically a gem file defines all of the pieces of software that you need to install in order to run your own application. So this is your first level of software dependency. And basically what this defines is usage, real usage. So everybody who publishes a project with a gem file is saying, I need these pieces of software, and we think that's a pretty good measure of popularity, kind of akin to success in the natural world, you know, why there are so many cockroaches and ants, that kind of thing. So given that basis, we have a long, hard think, who else does search well? I don't know whether you've heard of these guys. They're just a little company based in Mountain View who like to give you data in exchange for your eyeballs. And we go back to this concept of PageRank, which basically built Google as a platform. So looking quickly at PageRank, maybe we can take some of the factors of PageRank, some of the ways in which PageRank work, and apply them to code on top of that platform. So the next slide is my favorite slide. I would like to thank whomever it is that built this from Closteric for the crappiest photo of, the crappiest drawing of how PageRank works. So just to quickly describe, basically, PageRank works by saying you have a web page, and I'm going to value the content on that page on a scale according to how well it's written, according to things that you do on that certain site. And then I'm going to federate some of that value to each of the sites that you link to, and that will happen bidirectionally as well. So you end up with pages that accumulate a lot of value because effectively they've got the best content on them and people are linking to them. And that's basically how Google indexed the web. Taking that same approach, what we can do is actually unpack this file a little bit. So again, this is the gem file, and it is actually the gem file for libraries.io. Each of these projects will have their own dependencies as well. So we can take almost the exact same diagram, and we can just replace the links between websites with the links between software and their dependencies. And taking a leaf out of Clusteric's book, I've had my own go at a really crap diagram. So this is my most awful effort. And it's not actually factually correct either, which I think is always the best kind of basis for a crap diagram. But if you imagine we have applications at the top, which I haven't even named, and then at a first level we might have a project like Express, which is a popular web framework for building websites in Node. And then, in Ruby, let's say, it's actually Node, but I meant to say something else there. Anyway, whatever. So we have dependencies down the tree, so you might have dependency on something more elementary like Sass for compiling CSS, or down Rails, which is a basic engine for web application frameworks in Ruby. And then those projects might depend on something like Rack, which is a kind of deployment package for Ruby applications, and Rake, which is a build tool for Ruby applications as well. And what we can do is the same kind of accumulation of wealth. So if we value a project at the application level, we can federate some of that value down the chain so you get to these kinds of projects that are depended upon by a significant proportion of software up at the top level. But we need some other measures. So we need the equivalent of Google's measures of content, of the way in which content is presented, a way to value individual pieces of software. So we need to ask ourselves some questions. So as a software developer, if you want to use a search engine, you're probably going to ask yourself these questions. So does it have an open license? Can I actually use it within my organization? Some organizations have a policy of, for instance, not using a Faro GPL licensed projects. You might ask yourself questions like, is it easy to install? Does it have an active community? And you might be interested in that because you want to use the project, you want to know whether or not if you have a problem with it, you're going to get some support, and whether or not the maintainers are actually maintaining it, particularly if you're going to contribute to that project, if there's something that you think the project needs or you need to fix something that's wrong with the project, can you be assured that that will actually make it into the project in time? And then finally, you might want to do something about security. So is the project secure? I'm not going to go into that one because that's kind of my academic interest and it's a bit of a bigger question. But there is an argument to suggest that usage is actually an indicator that a project may be more secure, but certainly a lot of these factors kind of affect security. So with that kind of basis, where do we start? So we've got the basis for source rank. We're going to value a project according to some of these measures, and then we're going to federate some of that value down the dependency tree until we start accumulating value within those bigger projects that kind of underpin a lot of software as we know it. Well, we start with package managers. So this is a screenshot of currently Libraries.io and the package managers that we support, so 33 package managers. And what we do is use various techniques to garner all of the projects that are distributed on each of these package managers. Just back up a bit, if you don't know what a package manager is, it's just basically a really easy way of distributing software and installing software for your given language or platform or framework. So you have things like Swift, which is the language package manager. You have things like Homebrew, which is a package manager for OS X. You have a package manager, which is actually a big SVN for WordPress. And basically, if you're building a piece of software, you publish it on that package manager, and it enables people to install it very easily. So they provide a good starting point for us to map the world of software, because basically this is where people go to get their software. And the kinds of things that we can get from package managers. So not all package managers are made equal. I have roughly split package managers into 3 here, according to Meh. Crap package managers that basically just give you a name and then a link to a binary that you can download and run on your system. Some of them will link through to the source code as well. So examples that you'll have here might be things like Bower. Then you get slightly better package managers that will provide you a descriptive description of the project and what it does, provide a link through to the source code, provide a link to the repo where it's actually being built. homepage, licenses, and then keywords, which will really help you build something like a search engine later on. And then the best package managers also offer you versions, complete version history of that particular piece of software, and the dependencies that it has at that first level, which you can then unpack as you go through. And then what we do is we go through to the repo and we try and fill some of that information in. So currently Libraries.io supports projects that are hosted on GitHub, on GitLab, and on Bitbucket. And basically what we do there is try and fill in some of the blanks. So we can get things like licenses, we can get things like versions from the repo if they're not published on the package manager. But then we can get some really useful information like whether or not it has a README file, and we can store the READMEs so that we can provide those for someone who wants them in a search result. Change logs, really, really useful. If you need to maintain a project that depends upon something, you want to check out the change log. Indicators that it might be a mature project. A good project are things like, does it have templates for things like pull requests? So if you want to issue a change to a piece of code, is there a template that you can fill out to do that? And templates for issues as well to help the whole process kind of development chug along. Then you have factors that affect community. So who are the maintainers? Is it maintained by an organization? Is it an individual? How many contributors are on the project? How many commits does the project have? How many issues does the project currently have? And then a sense of activity. So how lively is the project? When was the last pull request merged in? How quickly was it merged in? When was the last commit? These are all things that as a developer you might want to know about a project. So they're things that you want to build into a kind of source rank metric for projects in a search engine. And there are various things that we have to do, various disgusting kind of problems that we have. We're not pretending that we're perfect when we pick up data from repos or from package managers themselves. We do have a lot of data, and it's given us quite a lot of experience in what those problems are. So at the time of writing, about like 12 hours ago, we had about 2.24 million projects, so unique projects that are distributed among those 33 package managers, covering around 8.4 million versions and 23 million repositories from those three platforms, so GitHub, GitLab, and Bitbucket. And amongst all of the repositories, so we basically just listen to the fire hose, use the API for GitLab and GitHub and Bitbucket. We know of around 85 million dependencies upon those 2.24 million projects. So going to some of the project problems that we've had, gathering this data and the approaches that we've taken. So licenses, this is SPDX. This is actually the package that we use to match licenses on a project. Some of the problems that we have is that often someone will not include a license.md. If you publish software, please include a license.md. Basically what SPDX does is it looks for kind of standard, normalized open software licenses, things like different versions of the GPL, different versions of things like MIT, and so on and so forth, and gives you a nice little list back of licenses that this project is published under. But you have glorious things that happen, like people hiding a license that just says, oh, this is MIT at the bottom of a README file, rather than the whole kind of MIT license or any kind of missives that are within that. And then you have people that take a license and they just edit it for fun, which isn't great, and we need to fill the holes in that data. Other things that we have a problem with, semantic versioning. So if you publish any software that anyone else depends upon, please use semantic versioning. It's really helpful. If you're not a developer, then basically all semantic versioning is a naming convention where you have numbers, dot, number, dot, number. And the idea is that you go major version, minor version, which will not break any issues. Not break any kind of interfaces, anything that anybody might be depending upon, and then patch, which are things just like quick fixes, bugs, and so on. The annoying thing is that sometimes people, in all their wisdom, use things like dates for the version, and even more annoyingly, dates sometimes look like semantic versions, which isn't great. Other problems that we have, so change logs. One of the things that we're really interested in is helping people maintain software. I'm going to talk a bit more about that. Change logs are really, really useful because they give an indication of what has just changed on a project. If we don't have a changelog, then we do some things to try to overcome that. So we'll include the diff between two versions. Basically, what you want to know if you rely on some software is whether or not you need to take a bit more of a deeper look at a change, or whether or not you can just merge it straight into your project. So yeah, changelogs not always present. We have a way of getting around some of the issues of that, but would be great if everybody includes a changelog. And then we have loads of missing data as well. So one of the biggest themes of this talk is going to be that we're not perfect, and there's a lot of data that we would like to get into libraries that we don't currently support. So things that are based around code quality, so a number of comments, like the comments that you have for each method and so on, kind of code coverage. Style, whether the code is going to be easy to read so that if you need to make any changes, that's an easier process. Performance of the code, so you can do things that you might actually be able to run the tests on a project and define how performant it is, although I'm not going to admit that that's a word. Do things like static analysis and so on and so forth. And then you've got the whole, am I going to be able to get any support for this thing? So we don't include any information about wikis that are associated with projects, or FAQs, either within that project's homepage or on the repo or elsewhere like Stack Exchange, or whether or not the project has a chat channel, someplace where you can go to communicate with people that are working on the project. And then finally, we don't currently really have a good understanding of activity, so the number of installations and potential deployments, although we have got some work that we've done on that recently. So the question is, going through all this effort, why are we bothering? Why we want to do all of this, and what can we get out of it? So the first point is what the mission of Libraries.io is, which is quite lofty. So we came up with this back in December. So the mission of Libraries.io is to raise the quality of all software, which is lofty, but it's worthwhile having good lofty targets, right? And we think we're going to do this in one of three ways. So we have kind of three themes that we work under. So the first is the one that we've spoken about predominantly, which is improving discoverability, improving search facilities, which we want to do directly. So this is a search for web framework licensed under MIT in JavaScript, and we have Express at the top there, which proves that my previous crap diagram was as crap enough to be wrong. And then we also power federate kind of search facilities for other websites. So we power search for libraries, and I don't have a slide for it, but actually not long ago, 2 months ago, Libraries.io was included in results in Visual Studio, so Microsoft's kind of IDE as well. And we think that's a really important thing because it accelerates a lot of the kind of evolutionary factors of open source. And one of the big problems, one of the big kind of issues I think we have in open source is the developers' tendency to scratch their own itch. So if you don't have good search, that's going to result in people just saying, "Oh, stuff this, I'm going to go and create something myself." Could potentially fall into the same traps as others have. And generally, I'm a big believer in combining efforts and sharing knowledge and so on. So I think being able to focus that stream down into projects that have already established themselves, have already got a good kind of basis to work from, and good contributors that have learned a lot of those lessons already, is a positive thing and will ultimately raise the quality of open source software. And not to say that projects shouldn't be incubated, and there's a good kind of reference point now emerging in open source where companies or individuals will be able to incubate a project as part of their job. Obviously, we need new software to solve new problems, but I'm talking predominantly about age-old problems, things like date utility and so on and so forth, don't really need solving a million times over. The second one is maintainability. So this talks about the point that I was making just a little bit earlier about if you have to maintain some software, it can be a bit difficult. And also, if you maintain some software, it's really difficult to understand who exactly your audience is. So 2 ways you can do this. Libraries.io, if you have an account, will let you know when there's a new version of any of your dependencies published and give you some information about that, which really kind of lowers the overhead of being a maintainer of a piece of software that depends on any kind of open source software. And then secondly, we can expose the usership of a particular project to the maintainers of that project. So this is looking at a package called Chew that's on NPM. It's like a really, really lightweight web framework. And what we do is we just expose all of the repos that we're aware of and the versions that were declared in their dependency files. So it gives you a really good understanding of which interfaces are going to be used amongst all of your kind of audience, which can inform product development. So if, for instance, you know that most of your audience are back on kind of 3.3, it may give you a little bit of information to determine where you take features beyond the kind of 5.0 level. And just kind of a good indication of where like a lot of your support load is going to come from and so on as well. And I find this is really, really valuable. There are very few people that are currently exposing this. GitHub are now starting to do that, which is great. I'd like to see a bit more of that. But this kind of information is really gold dust for anyone who's maintaining an open source project. And then finally, sustainability, which is where we go off on a little bit of a tangent and is actually the predominant reason why I joined Andrew working on Libraries.io. So this needs a little bit of unpacking. What does this mean to people? Anybody recognize this? Okay, so I'm going to imagine that if anyone's watching a live stream, that they're screaming at the stream saying, "Heartbleed." So this was a security vulnerability in OpenSSL, which is one of the key kind of pieces of software that underpins a lot of projects on the internet. It kind of does all the key cryptography and a lot of those kind of really important operations. And there was a bug, and basically the bug resulted in thousands upon thousands of people having to go and recycle all of their security certificates. So untold millions of dollars spent as a result of having to deal with this particular security bug. And what it did is really expose one of the kind of core problems in open source, which has been expanded upon by someone much better and much more eloquent than I. So this is lovely Nadia Egbal, who, with the Ford Foundation last year, wrote a report called Roads and Bridges, the unseen labor behind our digital infrastructure. And what it really did is unpacked the issue surrounding open source, its success, the amount of value that's extracted from that community, and the amount of value that isn't put back in. So there is an argument to suggest that Heartbleed was the result of a security vulnerability, and that no effort whatsoever could have potentially uncovered that until I think it was Google that spotted it. But there is another argument which I like to suggest, which is that OpenSSL up until that time had one person working on it, who wasn't being paid very much to work on it, wasn't able to work on it full time, I don't think, although I might be wrong on that. But that project underpins a considerable percentage, like 60% of the devices that are connected to the internet. And I think that is a major, major issue. If you're interested, I would recommend reading this. If you're a software developer or you work in kind of open source and you understand how open source works as a kind of community, then you don't need to read the first 80 pages. Yes, it is that long. But it is well worth a read. And I've done my best to abridge the kind of general sentiment of that report here, which I will read word for word. So shared public code makes up the digital infrastructure of our society today. In the face of unprecedented demand, the costs of not supporting digital infrastructure are numerous. No individual company or organization is incentivized to address the public good problem alone. In order to support our digital infrastructure, we must find ways to work together. So this is one of the kind of essential problems that we are part of the conversation trying to solve. So what can we do to help? I made this logo on the train on the way down here. I think it's awesome. So what we've been doing is conducting a number of experiments to see how we can use all of the data that Libraries has gathered to kind of prioritize projects correctly and to turn the attention of the kinds of organizations that are looking at solving the sustainability problem the right way. So the first thing we already saw, every single project that we have on Libraries.io has a /usage, which shows what kind of impact that project has. And that can help people who are behind those projects understand exactly how much of an impact their project has, and will allow them to talk about that with potentially employers, if they're employed to work on a project and they would like to work on their open source project, potentially directly with funders, to say, look, I think this is an important project, I would like to work on it, could you potentially give me some money to do so? And to just kind of have a bit more of a legitimate kind of argument to suggest that their project is worth more than just their kind of pet project. We have mapped what we call currently digital infrastructure. So this is the most established term for the kinds of project that underpin a lot of software on the internet and proprietary software that's used in companies as well. Basically what we did is we took all of the projects that we're aware of, all of the repos that we have, and mapped out the top 1,000 most dependent upon projects in open source. There is a caveat there. As I say, the theme of this talk is we're not perfect. We don't currently have good information on dependencies at the operating system level. And obviously the operating system is pretty damn important. Our goals this year are to kind of focus on getting parity amongst the kind of application level packages that we support at the moment, but that's definitely something that we want to do. Other caveats are just that some of the package managers that we support don't currently have dependency information. Some of them have dependency information, but we haven't yet added it. So that's a bit of a plug for if you want to contribute to the project, that'd be a great way to do that. Unseen infrastructure. So what we've done is publish an experiment that just shows some of the most depended upon pieces of software in the world as we understand it, that have very little attention. So they don't have things like stars, they don't have many subscribers, they don't have much attention upon them. We have another one which is bus factor. So really important pieces of software where there are fewer than 5 people who have the ability to commit code to them. So regardless of the number of people who are using it, and regardless of the number of people who say, oh, I've proposed a fix for this, if a small number of people were hit by a bus, that project would have a bit of an issue and everyone would have to migrate, and that'd be a bit of a headache for everyone. And then we have projects that are highly dependent upon that have open tickets that say that they want help with them. So this is a big kind of point of sustainability. And one of the first reasons why Andrew started building libraries was he came from a background of trying to get people to commit their time to open source. And this is a way of us aiding that kind of direct feedback loop in which people can contribute to projects that they directly depend upon in a way that will impact the widest potential kind of usership amongst the users of that project. So I've spoken a little bit about the data that we collect, some of the things that we have done with the data, and that may have you thinking about the things that you could do with the data. My response to that is JFDI. So we have an API where you can get a lot of information out of libraries.io, and later on this year, caveat, we're going to be releasing the data that we have in libraries.io on a probably quarterly basis, maybe biannual basis, under a CC by SA license for use in science and academia, in research. So if you think that libraries.io data could be useful for you to build like an application or to do a piece of research and so on, then we would encourage you to get in touch. The other things that you could do, as I've already kind of described, is if you want to add support for your favorite package manager, or you want to add better support for package managers that are already supported, then we've been working a lot on documentation to kind of bring people into the project and to help them do some common tasks and so on. So we're a very open kind of community and an open project for people to work on. And I think that's pretty much all I have, apart from to plug an event, which is being held on the 19th of June in San Francisco, which is about sustaining open source. So if you work on an open source project that you maintain and you find that stresses you out a little bit, or you're interested in how to support people who do work on open source projects that are maybe a little bit stressed out, we'd love to hear from you. And if you're able to attend an event, then you can go to sustainoss.org and get a ticket. We would just love to kind of come and hear from people and have that discussion and then move on. That's it. Thank you.
Brilliant, thank you. Just as a reminder to anyone watching online, if you have questions, please tweet them with the hashtag ODI Fridays. And in the meantime, I have a question, and I'm sure maybe some of our audience members have questions. Mine is just out of interest, really. You mentioned unseen infrastructure, so projects without much visibility.
Yep.
Do you have any examples of those?
Yeah, they're on the internet.
Or any of your favorite examples?
Yeah, so everything that I showed there, all those experiments, they're actually URLs, right? So if you go libraries.io and then you go / and that URL, you will see it. So if we look at libraries.io / unseen infrastructure, you'll find a list of projects right there. And this is just basically based on the metrics that we gather. So you'll find that there are some projects that have like institutions behind them. But here you go. So this is by most depended upon projects. So here we have Erebus, implementation of eRuby. And if it loads the page, how many people depend upon this? Let's have a look. Come on. There you go. So we have 313,000 dependent repositories. We have only 3 people watching it and only 1 contributor.
Wow.
So there's 1 person contributing, and there would be, if that person got hit by a bus, 313,000 individual people's projects that would be impacted by that.
Okay, thank you.
Yeah.
Does anyone else have a question? No? Hannah, have you got any?
Yeah. Thanks. You kind of talked about the different searches and things that worked before, but what was and didn't work before? What was the specific reason or the specific gap that you were filling when you created libraries.io?
So, I mean, Andrew would have a more honest answer to this, and mine is a bit of a proxied answer, but Andrew's background kind of came from the basis of being a pro contributor to open source. So he ran a project called 24 pull requests, which is like an annual give back to open source project where people are encouraged to commit to an open source project once every day of Advent. And that combined with some of the things that were going on in open source, the big kind of explosion of open source, and inability for Andrew to find projects that he wanted to work on or projects that he wanted to use, kind of led him to experiment with using dependencies as a good way of kind of mapping popularism in open source and finding software to contribute to or to use. So.
Thank you.
Well, what's your business model? How do you monetize?
All right, so because this is an open data talk, I have purposely not spoken about our business model, but if you want to go into that, that's fine. So one of the major problems that maintainers have is that as open source becomes more popular and more granular, people depend upon more and more open source projects. So a good example of that is React, so the Facebook framework, front-end framework. If you pull in that one dependency, you actually pull in around 700 dependencies. So if you can kind of think about your piece of software sitting on not a solid foundation, but a shifting foundation of sand, keeping a lot of that sand in order and up to date is a big overhead for companies, especially if you have lots and lots of projects or you have a kind of big monolith piece of software. So what we've done is used libraries' understanding of the open source landscape to build a tool that will help you get over that hump of maintaining your software. It kind of builds a lot of the measures that we have about a certain project into your development process. So what it allows you to do is say, keep my software up to date, notify me when there's an update to a piece of software, but also for new pieces of software that we build or new dependencies that we pull in, I don't want to expose myself to any of the risks like depending upon a project that has one contributor or depending upon a project that hasn't had any code committed to it in over a year because something's happened on that project. And that's Dependency CI. We launched that about a year ago, and this really is the kind of commercialization of that body of data. But we're doing it in such a way that this project will basically underpin Libraries.io, which is a not-for-profit kind of free utility service. So it is basically like the sustainability engine for Libraries.io, which as an open source project is a kind of a bit of a meta issue going on about sustainability in open source. So, yeah.
We've got a question from Thomas Middleton on Twitter, and he asks, in regard to commercial organisations, they're nervous about open source, lack of support and security issues, but could contribute lots. How do you feel we can get them on board, comfortable and an active part of the community?
So this could be potentially part of the solution. I think Tom's right that a lot of organizations are nervous about open source, but they're no longer able to police it. I think that we have moved from such a point that open source is another option to open source is the option. So I don't really like mentioning them, but Black Duck do an annual survey every single year on the kind of open source landscape. And amongst their partner organizations that commit to that survey, you can see a trend toward the things that I care about open source being that they're free and that I can contribute to them and there's a community kind of benefit to straight up like they've got the best features. So open source is part of the software stack for most big businesses these days. The risks are, it's an interesting problem. I mean, I think some companies think of risk as I need to find someone that I can point at if something goes wrong, and some other people think about risks as how can I mitigate them. For those who think how can I mitigate them, then contributing back to open source projects is certainly a way of doing that. Using Libraries.io to understand where those risks, as you might see them as an organization, are, gives you a way of kind of highlighting which projects you might want to commit to. And then just trying to understand where you should commit your effort to, how much you should commit to, and so on.
Great. Sorry, I've got another question. That's all right. Because you've created a search, a kind of search tool. How did you manage coming from a data perspective? How did you manage the standardization of
so
data?
there's a big normalization step, but that's a really important part of what we do. So a project has like a reasonably standard set of data that we collect about it, irrespective of where it comes from. So yeah, there's a lot of kind of normalization of data sources and what we have. A lot of fields are not mandatory. But what we've done in doing all that work is enable people who build features for a particular, like build it on top of the API. As soon as we add a project in Libraries.io or we add like a particular feature in Libraries.io, it'll be present for all of the package managers that we support. So yeah, it is a little bit of a hurdle. There's like a rough equivalency table for things like GitHub and GitLab and Bitbucket, things like stars and stargazers and so on. Yeah, all that's reasonably well documented, but it's just, yeah, it's a bit of a normalization step in the middle there.
Great, thanks.
I think since we're running a little bit late, we'd have to wrap that up now.
Okay.
But do tweet any other questions directly, and I'm sure
Yeah, just
we
grab
can get
us
back.
as well.
Yeah, brilliant. Okay, well, thank you so much. Thank you all for coming. Next week's lecture is on using open data to understand the causes of genetic birth defects, which should be really interesting. So do come along and join us then. Okay.